Culinary students, happy Thursday. So this is just a reminder, you're going to have a sub today, and even if you don't have a sub with you, you're going to be able to do the work just fine by using Canvas. So if you get into your Canvas page and go to Week at a Glance, you're looking at Thursday's agenda, and I'm going to have you scroll down, and this is where you're going to find the link for opening the video recording of today's lesson. Now, since I'm recording it right now, it's not linking in my presentation, but when you get to it tomorrow, it's going to totally be a link. So at this time, you want to make sure you have your earbuds in. If you don't have earbuds, or let's say your laptop is dead, feel free to buddy up with someone and just listen to this presentation with your volume somewhat at a reasonable level, so as not to be distracting to lots of people around you. So some way, shape, or form, you're going to totally get the lesson. So with that, what we're going to start with is we're going to look at the gluten experiment results, and we're going to talk a little bit about why it matters. So I want to show you why we were creating those basic doughs yesterday and building up the gluten, because you had a chance to feel the gluten and see the gluten. And then some of you were aware that we were going to bake those too then. And I want to show you the results of those and just kind of summing up why this all matters. So I'm going to switch my screen over to this one here, and we're going to talk a little bit about this gluten experiment. So in the pictures on this first slide, you can see all kinds of cool baked goods are going to have gluten incorporated, because anytime you have flour and liquid coming together, you have gluten forming. So with gluten, I want to just take a second to read this here together. Why is gluten so important? Without it, there would be nothing to hold the gas that makes bread rise. Think of gluten as the rubber of a balloon. The stronger it is, the more gas it can hold. But stronger isn't always better. For many baked goods like pastries and pie crusts, it's important to avoid gluten development. That's why different flours contain different amounts of protein depending on how they are meant to be used. A high protein flour will make dough with strong gluten, good for hearty yeast breads. Pastry chefs, on the other hand, prefer low protein flours that yield delicate, tender doughs. So now that we're not rushed, since it's not an early out day, I can show you what this experiment was meant to be. So basically how this experiment works is every group would have gotten a different type of flour and some water. And the idea, again, was to make a basic dough. Now, if we would have had a full class period, we would have actually needed it for an extra minute or two longer to really get that gluten going. And then we would have once again run the cold water over the ball of dough to get rid of the starch. That way we could see the gluten strands. And ideally, we would have had a little ball of gluten from each one of these so you could see the differences once that starch was rinsed away. Now, funny story, the group that gets the gluten-free flour always has a panic moment because their dough dissolves completely. So when they're running it under the cold water and through the strainer, it all just falls apart. Well, think about it. It's gluten-free. There's not going to be anything left. So that's completely normal, okay? So it'd be these top four, the wheat flour, the bread flour, the all-purpose flour, and the cake flour is what we would compare. And when we compare them, we would notice these stretchy strands. And this is a very zoomed in picture of this. And this ball has had a chance to actually dry out a little bit. But when you rinse the starch away, you can see the stretchy strands. And this is what we know to be the gluten. We could feel them because it's very elastic and very stretchy but we could also see them yesterday too. And I love this picture because we had talked at one time about how flour is like the framework of your baked good. Kind of like when you see buildings and homes being built around us. If you don't have that stud work, you don't have anything for all those house or apartment or condo or business buildings to build off of. Well, the same is true for gluten. If you don't have these gluten strands from the flour and liquid coming together, you don't have much else for all the other ingredients to work off of, and therefore you're not going to have a lot of shape to your baked good. Now, to see it in action, kind of flipped it there. I want to show you this video quick. It's really cool. This is one where they're going to show you the experiment. They worked with cake flour and then another flour here, bread flour, I believe it was. And so what you're going to see is like the steps that we took and what it looks now with two different types of flour. But then you're going to get to see just how strong the gluten can be and actually how you can blow it up like a legit balloon, which is really fun. So let's go ahead and play this. So I'm just going to play it right here in a little preview window. Here it goes.
We use wheat flour in countless recipes, from chewy loaves of rustic bread and pizza dough to tender cakes and some muffins. All of these baked goods rely on something called gluten. How does this work? First, let's start with a simple question. What is gluten? All wheat flours contain two important proteins, glutenin and gliadin. Now, in the presence of water, these two small proteins change shape and bond together. This creates an elastic network of proteins called gluten, which has the ability to trap air, much like a balloon. This gluten network fills with swollen starch granules and gas bubbles, allowing breads to rise and cakes to gain some gentle structure. Now, here in the test kitchen, we've long known that gluten is important in baking, but mainly we've done a lot of talking, not a lot of showing. So what is it on a tangible level? Can you see it? Can you feel gluten? I ran a simple experiment to find out just that. I made two basic doughs by mixing flour and water in a food processor until a smooth ball formed. And for one dough, I used cake flour, which contains the least amount of protein of all the different types of flour that you can find at the grocery store, between 6 and 8% usually. In addition, cake flour is often bleached, which further weakens the proteins. And for the other one, I used bread flour, which contains the most amount of protein, usually running about 12 to 14%, and is generally not bleached. So you can see here, I have two balls of dough, each containing a different amount of gluten. But you can't actually see that, because surrounding that gluten is a whole lot of starch. And the next step, believe it or not, I washed the starch away. I placed each dough in a mesh strainer and massaged them under running water to wash away all of the starch. Once the water ran clear, a sign that the starch was gone, I was left with two piles of essentially pure gluten. As you can see, the differences in appearance and texture of the two are dramatic. The low-protein cake flour formed a very small amount of really weak gluten. You can pull it right apart. On the other hand, high-protein bread flour formed a large ball of highly resilient, rubbery gluten. It can be stretched very thin without tearing. To show just how elastic this bread flour gluten ball is, I'm going to try and do something a little bit crazy. I'm going to treat it like a balloon and inflate it with compressed air. So, what did we learn from this experiment? Well, we use high-protein bread flour for breads because it develops a lot of very flexible gluten, which, as we've seen, acts like a balloon, trapping air and creating higher rising loaves. Now for cakes, we want just enough gluten to provide a bit of structure without turning them tough. We turn to cake flour for its lower protein content and reduced gluten potential. All-purpose flour, as its name suggests, is good for a lot of foods that fall in between these extremes, such as pie dough, heartier muffins, and cookies. So, next time you're kneading pizza dough, gently folding a cake batter, or considering swapping one type of flour for another, we hope you remember this experiment. This is one case where seeing really is believing.
All right, so you can see there just how cool it is, this idea of gluten. Now, obviously, I do not have a tank of compressed air in the classroom, but we do have the oven. And that's what we did next, is we took the gluten balls and we baked them in the oven to see what would happen. So I want to show you our class's results here. Sorry, that one's a little bit kind of jumbled over. Let me get rid of this one out of the way and we'll make this picture just a little bit bigger so you can see it. There we go. So this was from 2 of our classes yesterday. The other 3 classes, it had to sit for too long while I was in conferences with families, so those didn't turn out quite as well as what we wanted. So I'm just going to focus on these 2 pans here. I love this first set of gluten balls that came out. What was really cool, and I wish this one would have stayed, the moisture in them created steam and it blew all of them up like balloons. And this one was by far the biggest and stretchiest. And this one is one was as well. But the problem was, as soon as it came out of the oven and it touched room temperature air, which is obviously a lot colder than a 400-degree oven, they deflated rather quickly. So that's why you see them kind of wrinkled down here. These you can also see a little bit wrinkled down as well. These were not as highly risen up in a balloon form as what these were, simply because a couple of them had a lot of starch that didn't get rinsed out, and so that was weighing them down. But also, like, this one back here was just like incredible gluten development. I mean, there was hardly anything for the steam to stretch up against. It was just way too tough. So that's why you're seeing some of those differences. And this one again, so I'm giving you kind of a closer in shot. So see how it kind of wrinkled? Imagine like it was ballooned up bigger than like a softball, even like a shot put, like one of those bigger shot puts. So it's pretty impressive. So I'm trying to even think like maybe like a small cantaloupe. If you've ever been around a smaller cantaloupe, that's how big it actually got, which was like, oh my gosh, which is hard to believe when it's all sitting here deflated like this. So that's so sad. I want to show you some other pictures though in the past when we've done these. So these were a lot smaller scale, but it gives you an example of what some of these different flours look like. So all purpose, you can see these little parts in here. These were bits of starch that were not rinsed out all the way by those students. Kind of same thing up here with the cake flour. Definitely a lot smaller in size compared to the remainder of them. The wheat flour ballooned up pretty decent, but it was the bread flour, just like what you saw in the video when they're using the compressed air here, like how balloony that got. Yeah, because it's like uber stretchy and it can withstand a lot of that steam pressure building up against it. So it's just fun to see how gluten can respond in each of these different flours, which starts to make sense then why we have different flours available for different products. So just like the video talked about, cake flour, we want to use that for tender items because there's not as much gluten present. And you can see the percentages here. So you are going to get a lot more tender, delicate product in the end. All-purpose flour is kind of like right in the middle. That's why it's good for anything, really. I mean, that's why they call it all-purpose. But if you look at now whole wheat flour and bread flour, you can see the percentages are much higher. And that's why you're getting more specified products that you're wanting to use these flours for. Now, a good mention for whole wheat flour, you're typically not using like all whole wheat flour. It would just be way too dense, and oftentimes it gets a little bit too earthy for people. So with that said, usually you're using a combination, I don't know, like half whole wheat flour and then half all-purpose flour in whatever it is that you're baking, just so it doesn't get too weighted down and losing out on flavor potential. Whereas bread flour, oh heck yeah, if you're making yeast breads, this is a great flour choice to use because you've got more opportunity for gluten and to get those heartier bread qualities in the end after baking. And if you take Culinary 2, that's typically when you're going to get a chance to work with some bread flour. You'll do some all-purpose and maybe a little bit of whole wheat. It's really going to depend on what your teacher prefers. But if you get a chance to work with that bread flour, that's some pretty cool stuff, and you get some really great bread textures there. So with that said, that's kind of our wrap up on this whole gluten experiment. If you have any questions, feel free to write those down, pass them along to the sub if you have one in the room with you. Hopefully, but if not, you can just write them down, or you can email me those questions too, and we can kind of go from there. Now, since 3 of the classes gluten balls did not turn out, we're not going to eat the ones that are sitting out on the demo table. I know a couple of you are like, oh, we want to eat them tomorrow. Since I want everyone to be able to see what these look like, we're going to just leave them be for today. Don't eat them. Don't go squishing them. So leave your hands off because you got dirty hands. So let's let every class have a chance to see the results. And then tomorrow, if there's anybody still wanting to eat the ones that were actually up on display, that's when you can have a chance to do that. Okay, so up next, I need you to get out your quick bread article questions that you should have answered. And we're going to start going through some of those answers together since over half of them will be on your assessment next week. So while I am switching over to the next video, I need you to get those article questions out.